And while that loads up, once again, my name's Eric Seamon. I'm the Environmental Data Manager for a project called the Regional Approaches to Climate Change for Pacific Northwest Agriculture, or REACH. Sometimes you may have seen that name and logo multiple times during this conference. So I'm going to talk a little bit about our project and give you a brief overview, but I first wanted to just briefly outline what I'm going to talk about. And to start off with, I'm a technologist, and I'm going to take a step back a little bit from the more specific climate science discussion to talk about how many federal agencies and our project and many other projects are using some unique technologies to integrate data, some of the data sets and information that you've seen at this conference. So I'm going to talk a little bit about the kind of perception and reality of the use of data and where I think we're going in terms of funding and in terms of the interaction of data between different groups and different individuals, why that integration is important, talk a little bit about tools and some of the tools that we're using in our project and how that might be applicable to a project that you might be on, or as an individual scientist, or as a policymaker. And I'm going to talk at the end about our project very specifically. And my presentation is here. I know that's a very long URL, but you can go to reachpna.org and go to our publications library, and you can just search for my last name, and you'll find this presentation. REACH, you've seen this name probably several times. There are actually 6 posters and 3 presenters that are part of our project. It's a coordinated agricultural project, a CAP, that is funded through the USDA and the National Institute for Food and Agriculture. It's one of 3 $20 million climate science-focused projects around the country, ours being focused in the Northwest, and there's another one in Iowa and another one in Florida. We have roughly 150 scientists at Washington State and University of Idaho and Oregon State that are working on these particular areas in cropping sciences and climate modeling, sociological impacts of climate science and perception. So it's a very diverse project, and I would encourage you to check out the posters. And once again, if you go to reachpna.org, you can get more information about that. What I wanted to initially talk a little bit about is what I think is fairly typical of in terms of most of you go through the scientific process of doing your research. It gets reviewed, a publication is created, and from that, policy and climate perception and funding and regulations get implemented. And that's a model that has been used for a long time, and that has, worked very well for the scientific community. However, I think that, and as you have experienced in probably looking at some of this work and research that has been going on in the Northwest, that it's not just about the outcome of the publication, but now we have models and other data, other programming code, images, video, a lot of content that is getting created from this research that is also very valuable, and that also has an influence on policy and regulation and the perception of climate. And so what does that mean in terms of collaboration? We now have large groups or individuals who are producing large data sets. You've seen a lot of that at this conference. How do those data sets intermingle with each other? I mean, we've got somebody working individually, they create an output. What happens to that output? Well, I mean, we know for a fact that the model is really moving towards one where you are producing these outputs and there's a collaboration effort, an effort to interlink that data. And when those data sets become not just stored in one location, but they become usable and able to examine that data in combination, that you create more value and thus more influence in the policy and regulation and perception and funding areas. And our project is one that is like that, and I think that you've seen several projects that are focusing on those efforts. So why do that? What's the value? There's tremendous values in terms of the usage and storage and recovery of the data, the ability to integrate the data, the ability to structure and organize it so you can examine multiple models at the same time or multiple individuals' data sets and be able to maybe achieve a different understanding of that data that you may not understand in a silo. It does require a lot of time and commitment, and oftentimes folks are very busy and they may not necessarily have that time. But I think as time goes on, many are realizing that there's an inherent value in that, and we really want to allocate that time and energy to be able to do that. The other thing that I wanted to mention is that there's been a recent article in Nature that discusses this component as it relates to the National Science Foundation, and I think I've got it listed here, from January, where there was a specific policy change that incorporates data products into NSF's policy regarding submittals for funding. So NSF, as well as I think the USDA and other federal agencies, see the value of data. And it's not just about the publication, but it's about that information that resides or has created that publication. So I think you're soon going to see that as a requirement for getting funding, that you're going to provide your data products in a way that can be integrated with other scientists and other groups. So our data model, which is one that is fairly heterogeneous, is one that is used by many different organizations. And I've just listed a few here, but NOAA and the EPA, NASA, the Geospatial One Stop all use, for example, they all use a product called GeoPortal Server, which is a harvesting web server technology that integrates data sets, that lets you harvest a data set from one location and integrate it with another data set. So we are using this model, and I think that this is the future for interconnecting data sets. It's very extensible, and many folks are using this. And these are just a few of the organizations. Okay, so this was my one-slide summary of my presentation that I sent to Phil. So what I'm trying to convey here is the chaotic nature of data, and that I think we all understand and all can get a sense of data that is locked up. It's an individual has it, a group has it, but nobody else is seeing it. And so that certainly doesn't have any influence on climate perception or regulations or funding or policy. So how do we go from the left portion to the right portion? How do you get to a point where you can get information easily and understand it and make decisions that are not just based on one single grouping of data? And so we're trying to take this approach of data and metadata. You're going to hear this word metadata a lot, not just from me, but from other folks. Data about data. And it really is essential. I'm not going to go into it, but if you are involved in a lot of large data processes, metadata is essential. If you don't understand your data, where it is, or how it was created, it becomes less valuable. And so I think with the plethora of information that you're hearing at this conference, you can understand that it would be very easy to be totally overwhelmed with the information and what that actually means in terms of a policy decision. So I think technology can be used to assist in clarifying that, and metadata is one component to that. Certainly systems and applications and methods of storing the data and processes are an important component. On the left, I've just mentioned a few technologies that I'm going to briefly go into, and I'm not going to really bomb you with a bunch of tech information, but I just want to mention a couple. The Threads and IPython are two technologies that are being used right now in varying ways, but they are both very powerful technologies that I think you're going to hear a lot more about. Threads, thematic real-time environmental data distribution services. I know it's a big, long name, but it essentially enables us to take data sets that you have seen, NetCDF data sets, data sets that are multi-dimensional, time-based. They may have, much of the modeled data sets that you're seeing are NetCDF data sets. Threads allows you to aggregate that data in real time across different variables and present you with that data. So I might have 50 data sets of precipitation from 1950 to 2010, and I want to aggregate that data based on a variable and on a time frame. And so I can go and use this server, make a request, and it provides me with that NetCDF file. And that's pretty powerful. You can also shape it out by geographical area. So I could say just this precipitation variable over from 1950 to 1952 for this area. Give it to me. I don't want the 20 gigabyte file of all of the Western United States. I just want this one little bit of data. And so that's what Threads does. And it's very powerful, and it's being used by many organizations to expose their data. And I'm going to show you some screenshots of that in just a second. IPython, interactive Python, developed by some folks at Berkeley in the last 2 years. It essentially enables you to use Python to be able to access data through a web browser. And I'm not going to go into what Python is. It's a very powerful programming language that many people use to access data. And so we are using that on the REACH project to be able to integrate our data sets and create essentially research notebooks. And if you go online and you just do a search for IPython, you will see researchers who have essentially created their entire research process in a research notebook, and they can run it right there in the browser. That is a data product. It can be published and provided to somebody, and it actually enables them to run your analysis. That's pretty powerful, as opposed to a publication that somebody reads, very important, but it's only the publication. And certainly I understand that sometimes you don't want to provide the data for that publication, but in other instances, it's very compelling information. And why do you care? Well, you care because integrating these data sets is an essential aspect to being able to truly, I think, understand what's happening with our climate. And the more integration and ability to interconnect those data sets, the better understanding we're going to have. And I think that there's no doubt that this is where things are going. And so I'm going to briefly talk about Threads and show you a couple screenshots of that in IPython. And I'm also, I'm not really going to talk about ArcGIS Server and JavaScript, but that is a geospatial technology to be able to map data, and it really interconnects with these other two areas. And some of you who are using geospatial technologies, you're probably aware of ArcGIS and ArcGIS Server. We're using that to spatially enable all of our data on our project. Okay, these are some URLs that you can go to check out our data. However, we're in the process of opening it up to the public, so it's still locked down. So if you're interested, you can email me, and with the appropriate approval, we could assign you a login. But hopefully in the next month or so, we'll be able to open these up, and these domains will be live. This is our search engine. So it is using GeoPortal Server, which is again, I had mentioned, it's a product for cataloging data, and essentially allows us to be able to harvest data. So I can harvest data from a location, not have to move it to my server, but I can harvest it. You can search for it, and then it takes you to that data. So you could have 20 different data sets or 20 different locations of data all over the place. This brings it together. And so if you go to NOAA's site or you go to NASA's site, that's what they're using. They are harvesting data from all these locations and presenting it to you. And it's Linux, Tomcat, Java base, running on a Linux server. And if you want more information about that, I can definitely provide that. Threads. This is an example of a Threads catalog. So I've taken our downscaled modeled data that our researchers have worked on, and I have aggregated that data based on time, based on the particular particular variables that may be included, and then represented that to users to allow them to extract the data. So in this instance, I'm going to select one of our catalogs, which is our CMIP5 catalog. And I've aggregated all of our data. In this instance, this is just one view of several different models, and I've aggregated them based on a time period. And so I select one of these, say the first one, 1950 to 2005, for a particular scenario. It presents that data set to me and it gives me metadata about it. It says who created the data set, where did it come from, what are the specifics about it, and it lets me look at all kinds of ways of accessing it. I can look at it through OpenDAP. I can just download the data if I really wanted to. I could look at the markup language. I could look at the NetCDF subset, which is the coolest thing. It actually allows you to take this data set, and then I can say, oh, select the variable, select the area, give me a time frame, and then give it to me. And it runs and gives you that data set. And I'm not going to do anything live, but I've done that before. Creates like a gigabyte data set in 30 seconds. So I think that's very cool, because previously you'd have to go to somebody, get that data, make a request. They have to crop it out for you. Very time consuming. And then I could provide that to somebody and they could actually run it against my data. And so this is an example of just 2 lines of code. I'm using some IPython code to actually build a URL and present data. I'm saying, I'm interested in some anthrome data. Anthrome data, essentially agro-ecozone data that has been taken from the USDA cropland data layer and used to create agricultural ecozones for an area. I'm making a request to say, give me that. And it's presenting the data back to me, and I can look at the metadata, I can download it, I can preview it. And so I can, it's actually interactive data. So I could click on one of those and it would take me to the data set. This is just another example, but there's so much. I can use various modules of IPython. If you know IPython, there's a very famous module called matplotlib, which lets you do all kinds of plotting and statistical mapping. So with like 10 lines of code, I can create all kinds of data sets, all kinds of views of data. Okay, I was going to show an IPython example, but I don't have enough time. But I would if you're interested, you can contact me, and I can provide you with access to notebooks through GitHub, the GitHub repository online. And okay, the presentation takeaways from this, again, is that I think that data integration and collaboration are here to stay. And the methods of doing that are very important and valuable. And as a scientist, I think it would behoove all of us to embrace this to a certain extent. And I certainly understand the issues of privacy and confidentiality. Those come into play. But I think we all agree that openness and transparency are very important. And the other items I want to mention, metadata and harvesting and aggregation, geospatial aspects, are all essential components of climate science analysis. And I think the more that we embrace those, the more we're going to be able to make good decisions and provide good information for policymakers in terms of climate science.